Welcome to Brain Vision.
Hey guys, let's do problem 93. Assuming ideal gas behavior, we need to derive this given formula. Let's do that. The charge for propane is the product of the cost per pound and number of pounds per hour. The charge for propane is the product of cost per pound and number of pounds per hour. Therefore, the cost per hour is equal to pounds per hour, the cost per pound multiplied by the number of pounds per hour. We can name this equation as equation 1. Now we can assume that the gas is ideal, and then we can get the molar flow rate of propane. The molar flow rate of propane N is equal to volume flow rate multiplied by pressure divided by RT, and we know the molar flow rate of gas is the ratio of the mass flow rate to the molecular weight. Therefore, molar flow rate is equal to mass flow rate divided by the molar mass. We can combine these two equations and we can write mass flow rate is equal to and we can insert this value of m to the equation 1. Let's do that. Before that, we know that the molar mass of propane is 44.09 pound per pound mole. Therefore, we can write it down as well, multiplied by 44.09 pound per pound mole divided by RT. Now let's insert this equation in the first equation. Therefore, we can write divided by RT. Now let's use the constant R here. Therefore, S multiplied by VP 44 pound per pound mole divided by gas constant, which is 0.7302 feet cube ATM mole pound inverse 1 Rankine multiplied by temperature. And as we do this calculation, we will get 60.4 S multiplied by volumetric flow rate multiplied by P divided by T. Therefore, this is the relation that we get. This is the equation we had to derive. The next problem says calculate the charge for propane stream. We know the critical temperature and critical pressure for propane is 369.9 Kelvin, and the critical pressure is 42 atmospheric pressure. Let's convert the critical temperature to the Rankine scale. Therefore, the temperature is 665.8 degree Rankine. Now let's calculate the reduced temperature and reduced pressure. So reduced temperature is 0.85 and reduced pressure is 0.16. Now for these two, reduced temperature and pressure, the Z value is 0.91. Now we can use the compressibility factor equation of its state. Let's do that. We know PV is equal to Z N RT, or number of moles is equal to PV divided by ZRT. We know that number of moles is equal to mass divided by molar mass, or mass flow rate is equal to volumetric flow rate multiplied by pressure multiplied by molar mass divided by ZRT. Let's insert all the values. The molar mass is 44.09 pound per pound mole divided by 0.91 multiplied by 0.7302 multiplied by the temperature, and then we get the relationship, the actual relationship. Let's substitute the mass flow rate in equation 1 and get the actual formula for the cost. Which is 66.4 S multiplied by volumetric flow rate pressure divided by T, and it is the actual formula. Now we should use this actual formula and calculate what is the charge. Therefore, from here see that the actual charge is more than the that charge to the customer. And the percentage undercharged by the plant is 66.4 minus 60.4 divided by 60.4 multiplied by 100%, which gives us 9.9%. Therefore, the customer is charged 9.9% less than the actual charge.